Hello everyone. Today I am going to explain about regression or a regression analysis. What is regression? What are the lines of regression? I will explain in detail and then we will do the problems. The term regression literally means the literal meaning of regression. First I will tell you. The term regression literally means stepping back towards the average. Stepping back towards the average. What is it means really we will see. The actual definition is regression analysis is a mathematical measure. Why we are using this mathematical measure we will see. Regression analysis is a mathematical measure of the average relationship between two or more variables in terms of original units of data. The average, to find the average relationship between two or more variables in terms of original units of data, we use this regression analysis. In regression analysis, there are two variables. Now, these two variables, x variable and y variable, what it stands for, we will see. The variable whose values are influenced or can be predicted is called dependent variable, and the variable which influence are used for prediction is called independent variable. In regression analysis, the dependent variable is known as regressed or explained variable, while the independent variable is known as a regressor or a predictor or a explanator. These about two variables x and y, the two variables. Now one is independent variable, one is dependent variable. Now very important one is lines of regression. Now what is mean by lines of regression? What is the formula of lines of regression? We will see. If we plot lines of regression, if we plot the points of the bivariate distribution in the scatter diagram, the points will cluster around a curve called the curve of regression. You will get the points like a cluster around a curve. Now this is called a curve of regression. If the curve is a straight line, then it is called line of regression. If you all the points in a bivariate distribution in a scatter diagram, the points will get as a curve. This is called curve of regression. If the curve is like a straight line, then it is called line of regression or a linear regression. Otherwise, a linear regression or line of regression. Otherwise, it is said to be non-linear regression. Lines of regression. What is mean by lines of regression? X on y, y on x. What is it stands for? We will see. Lines of regression, very important. Lines of regression, y on x is the line which gives the best estimate for the value of y for any specified value of x. Y on x, line of regression y on x is a line which gives the best estimate for the value of y for any specified value of x. In the same way, similarly, line of regression x on y, line of regression x on y is the line which gives the best estimate for the value of x for any specified value of y. This is the notation of a line, the regression line x on y and y on x. And what are the formulas? We will see. Now the next one is types of regression. Types of regression: simple regression, multiple regression. There are two types of regressions are there. One is a simple regression, another one is multiple regression. Simple regression. The regression analysis is confined to the study of only two variables at a time. If you study about only two variables at a time, then it is called simple regression. Now multiple regression. The regression analysis is for studying more than two variables at a time. The regression analysis for studying more than two variables at a time is termed as multiple regression. Now the next one is utility of regression test. Utility of regression test. Now see how to find the formulas of regression, lines of regression x on y, y on x. We will see with including with examples. Regression lines. Regression lines are useful. Why we are using these regression lines? Regression lines are useful in predictions of values of one variable for a specified value of another variable. Prediction, to find the predictions of values of one variable for specified value of another variable. Example, when price and demand are related, we can estimate the future demand for a specified price. This is the best example for regression lines. Now the second example is, when a crop yield depend on amount of rainfall, then the regression test can predict crop yield for a particular amount of rainfall. This is also one more important example of a utility of regression test. Why we are using the regression analysis, regression test, when we can apply regression test, at what time we can apply regression test. Now the regression line x on y, y on x. Let x and y are two variables. Let x and y are two variables for the regression analysis. Then there will be two regression lines. They are regression line x on y. Another one is regression line y on x. Now regression line x on y. This is a very important formula. Second one box, whatever I have put one box. This is important to do the problems also. Regression line x on y. Regression line x on y is equal to x minus x bar is equal to r into sigma x by sigma y into y minus y bar. Line, straight line equation. What is the straight line equation? Y minus y1 is equal to m into x minus x1. M is a slope. Slope formula is y2 minus y1 by x2 minus x1. Like that. The same way, lines of regression. This is a line. That's why that formula, straight line formula, I am writing. Y minus y1 is equal to straight line, equation of the straight line 2-point form. Equation of the straight line 2-point form. Y minus y1 is equal to m into x minus x1. What is m? M is a slope. Slope formula, m is equal to y2 minus y1 by x2 minus x1. In the same way, like that only. But here regression line x on y. X minus x bar is equal to r into sigma x by sigma y into y minus y bar. Now if you cross multiply sigma x by sigma y, r into sigma x by sigma y is a regression coefficient. In the next step I will tell you, r into sigma x by sigma y is bxy into y minus y bar. This is the very important formula. Regression line y on x is equal to y minus y bar is equal to r into sigma y by sigma x into x minus x bar. This r into sigma y by sigma x is a byx, regression coefficient byx. This is another formula. The intersection of two lines x on y and y on x gives the mean values of x series. Intersection of these two lines x on y and y on x. Intersection of two lines x on y, y on x gives the mean values of x series and y series. That is x bar and y bar. While doing the problems we can use this one. Now this how to find bxy, byx I will tell you. Now how to find, just if you want you can go through, otherwise very simple, easy. In practical problem, bxy calculated as follows. Bxy, how we have got a bxy, byx. How to find bxy? Bxy is equal to sigma r into sigma x by sigma xy. If you see, if you go through once, you can easily understand this one. R, small r is always correlation, Curl-Pearson correlation coefficient. R is a correlation coefficient, Curl-Pearson's coefficient, correlation coefficient. If you go through once, you can understand. Bxy is equal to formula we derived. Either this or this, both are same. In the similarly, we can write from this, we can write byx is equal to either this or this one we can derive. Bxy is equal to formula, byx is equal to formula, important formula. Bxy is equal to, remember this formula, byx is equal to, remember this formula. To do the problems, this is very useful. Bxy and byx. Regression line of y on x. This is also using principle of least squares we derived. You can go through once. Regression line y on x, x on y. Using the principle of least squares, we can derive this line of regression as follows. In this manner, this is the formulas of a straight line of principle of least square. Using this formula, we can derive. Difference between correlation and regression. Difference between correlation and regression. Go through all the points. You can go through. If you read, you can understand. Now first problem, we will see the first problem, how to do the first problem. I'll read the question. How to do this problem is if the two regression lines are given, how to find the regression coefficients, correlation coefficient. I'll read the question. The following are the regression equations. The two regression equations are given. The following are the regression equations, and the regression line, find the regression line x on y, y on x, and also find x bar and y bar, the regression coefficients, correlation coefficient. Now here two regression lines are given. You have to find the regression line x on y, y on x, x bar and y bar, regression coefficients, correlation coefficient. All these things we have to find. These two equations are given. Solution. To do such type of problems, now write down that whatever the equation, first equation, 8x minus 10y plus 66 is equal to 0. I am rewriting the first equation, 8x minus 10y is equal to minus 66, equation 1. The second equation is 40x minus 18y is equal to 214, equation 2. The two equations I wrote like this. I rewrote the two equation 1, equation 2. Now I am solving these two equations for x and y. Now just like solving ordinary solving, I am solving these two regression lines for x and y, and I cancelled x on both x, and y is equal to 17 I have got. After y is equal to 17, if I substitute in any one of the equation, I have got x as 13. After solving these two equations, I will get x, and x means x bar. We have to take as x bar. X bar is equal to 13, y bar is equal to 17. After solving these two equations, we will get x bar is equal to 13, y bar is equal to 17. And then we will find regression lines. Now second bit, we have to find the second bit. Rewrite the equations. Rewrite the equations of a regression to get from x on y and y on x. Now we have to find regression line x on y and y on x. To find the regression line x on y and y on x, we will rewrite equation 1. What is our equation 1? 8x minus 10y plus 66. 8x minus 10y is 8x minus 10y plus 66 is equal to 0. This is equation 1. This equation I am rewriting. Rewriting is equal to, if you send the minus 10y outside, 10y is equal to 8x plus 66. This is in the form of, therefore we can write y implies y is equal to 8 by 10 into x plus 66 by 10. This is in the form of y is equal to a plus bx. Y is equal to 8 by 10 into x plus 66 by 10. This is in the form of y is equal to a plus bx. A plus bx. Y is equal to 66 by 10 plus 8 by 10x. Therefore, byx is equal to 8 by 10. Byx. This is the byx. If you compare this equation, b is equal to byx is equal to 8 by 10 is equal to 4 by 5. Now second equation. The second equation I am rewriting. The second equation 2. Equation 2 is 40x minus 18y is equal to 214. Minus 18y is equal to 214. I am rewriting the second equation. 40x is equal to 18y plus 214. Therefore, x is equal to in this form. If you compare this one with x is equal to a plus by. If you compare this one with x is equal to a plus by, you will get x is equal to like this. Now, in this one, whatever, a plus by, this one, this is in the form of, if you compare a plus by, bxy is equal to 18 by 40 is equal to 9 by 20. Now, therefore, regression coefficient x on y is equal to x on y is equal to 9 by 20. Regression coefficient y on x is equal to 4 by 5. Regression coefficients, and correlation coefficient r is equal to, this is the formula, correlation coefficient r is equal to plus or minus under root of byx into bxy plus or minus 9 by 20 into 4 by 5. Just now we have got. Now that is equal to plus or minus 3 by 5. Plus or minus 3 by 5 is plus or minus 0.6. Since both regression coefficients are positive, these both coefficients are positive, r must be positive. This is the formula. If you substitute plus or minus 0.6 we have got, but both these two are positive, that's why r also must be positive, 0.6. Like this you have to do. And thank you.